if I wanted weather like this, I would move to South Dakota. That's just me. I am not a snow person at all. I'm absolutely tired of our cold weather. I'll be really glad in another week or so when we start to warm up and get to 40. So, what's that? Yes, absolutely. So we're continuing on with our lesson 2. We're probably going to finish this up today, and we may actually start into lesson 3 on evolution. And what we were talking about was the origin of the universe, cosmology, the 2 different theories. We talked about the Big Bang Theory, we talked about creation, and where we had ended last week was talking about this concept of creation by design, the idea that the universe seems to be fine-tuned for our existence. Now, we know the reason why that's the case. To try to explain that to a non-Christian, to a non-church person, that's what we're looking at here. So what I want to do is sort of quickly review the ones that we talked about last week and then continue onward from there. So we had talked about the necessary elements for life, specifically carbon, that should not exist, requires a very specific energy level. Whoops, I did it again. I did that last week. There we go. That it shouldn't exist in the quantities that it does, and that the existence of carbon and the formation of carbon leads to the formation of the other heavy elements that we need for life and for the rest of the universe. The mass of the proton and the electron we talked about last week. The proton in the center of the nucleus, 1,836 times heavier than the electron, and if those mass values were very slightly different, we would never get the formation of molecules. This is, in a lot of ways, for me being the physics guy, this is one of the big ones, the relative strength of the fundamental forces. Gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Specifically electromagnetism in this particular case, that very slight differences in those forces would make it so that the universe couldn't support life. The universe wouldn't even exist if the electromagnetic force was a little bit stronger. Chemical bonds would form and never break. If the electromagnetic force was a little bit weaker, chemical bonds would never form. They would just blow apart. And even for that matter, this one tied together with the mass of the proton and the electron, if the electromagnetic force was a little bit stronger, the electron and proton would pull themselves together and atoms would never form, getting even more fundamental than molecules. If the electromagnetic force was a little bit weaker, you would never get the formation of atoms. The force wouldn't be strong enough, the proton wouldn't attract the electrons would blow off, and you would never get the formation of atoms. We talked about proteins, more specifically functional proteins. Proteins, one of the main building blocks of all living things. And of course, the Big Bang Theory mindset is that all of this is random, and the chance for a random formation of a functional protein, 10 to the 40,000th power, that is 1 followed by 40,000 zeros, and that there are only 10 to the 80th atoms in the entire universe. So thousands of orders of magnitude less likely for proteins to just randomly form, and not just here on the Earth, but anywhere in the universe. And I think this is probably where we had stopped last week. The balance of gravity and the electromagnetic force in stars. I think this was the last one I had done last week. The way stars work is that there is a reaction called fusion. Heavy or lighter elements slam together and form heavier elements, and in the process release energy. Einstein's E equals mc squared. That energy pushes outwards. Now, if that is not controlled, you get a thermonuclear explosion, all right, the hydrogen bomb. But in a star, you have the gravitational pull of the mass of the star that pulls that stuff together. The electromagnetic force is pushing outward, the gravitational force is pulling inward, and those two things are in balance. As long as those are in balance, the star does what it does. If those forces were only very slightly different, either the star would collapse inward and never produce energy, or it would explode and never form into a star. As stars age, those balances change. It's one of those things that I hope I live to see it. The constellation Orion, you all probably know the constellation Orion. It's the one that's out there this time of year. It's the square with the 3 stars across it. The top right corner star is, and if you look at it, it's very obvious. The top left corner star, I'm sorry, is a very bright red star called Betelgeuse. Betelgeuse is a red supergiant. It is like the 95-year-old guy of a star. It is a very, very old star that is like on its deathbed. This balance is starting to get out of whack, and it's going to explosively expand into something called a supernova. When that happens, and astronomers believe that that could happen literally at any point, things have been happening to it that sort of give us the mindset that it may be getting ready to happen. It might happen today, it might happen tomorrow, it might happen 1,000 years from now. From an astronomy standpoint, that's like overnight. If and when that happens, we will have another, I mean, you go outside, you'll see another star in the sky, as bright as the sun, for about 3 or 4 weeks. Nighttime will no longer be nighttime when this thing explodes. And it's all part of that balance here of the electromagnetic force and gravitational force. 1 divided by 10 to the 40th power. So that's 1 divided by 1 followed by 40 zeros. That amount of difference in the gravitational force, and either they explode outward like Betelgeuse and they never form, or they compress inward and they never form. The low entropy start of the universe, the idea that entropy, chaos, disorder, that second law of thermodynamics we talked about a couple of weeks ago, that the universe started with a low level of disorder, that the universe is relatively ordered from an explosive expansion, this potential for order, and yet if the universe started with this Big Bang explosion, shouldn't we be starting with a very high level of disorder? Again, no good explanation for that one. It totally violates that second law of thermodynamics. And the key with physical laws, and that's one of the things that you need to keep in mind, the key with physical laws, whether it's the law of gravitation, whether it's Newton's laws of motion, whether it's the laws of thermodynamics, from a scientific standpoint, laws have to apply everywhere, all the time, no exceptions. There's no way you can have a violation of the second law of thermodynamics. It's one of the things, as we talked about, many scientists studied the universe and studied different aspects of science to understand how the universe is put together, because those laws, those rules, are the fingerprint of God. Those are the things that God put in place to make the universe work, because that's the way he wanted to do it. They don't just happen randomly. The balance between expansion and collapse. We talked about the Big Bang, this idea of this super dense particle of matter explosively expanding outward, and that's what created our universe. That's what the secular scientists would have us believe. And that expansion, and this is one of our new ones, that expansion is perfectly balanced by gravitational attraction. If the gravity was a little bit stronger, the universe never would have come into existence. It would have collapsed in on itself. It allows galaxies to form. There's enough gravitational pull to make clouds of gas come together into stars, and stars come together into galaxies, and yet it's not so strong that that explosive expansion didn't just collapse on itself right at the very beginning. Again, they don't have any really good explanation for how that is so precisely fine-tuned. I take that back. They do have that explanation. We talked about it last week. That many worlds theory, the idea that there are many universes, and the reason why we see a universe that seems to be fine-tuned for our existence is because we're here to see it. If the universe wasn't fine-tuned for our existence, we wouldn't exist, therefore we wouldn't be able to see it. Nice circular argument. I love that one. Very nice circular argument. The balance of matter and antimatter. How many people have ever watched Star Trek? All right, I love Star Trek. They talk about their spacecraft are powered by antimatter. Now, antimatter was something out of science fiction. It was something that was theorized up until the 60s, until they actually discovered it. Everything that we see in the universe, every physical object we see in the universe is made of what we call matter. Protons have a positive charge. Neutrons have or electrons have a negative charge. Neutrons have no charge. They're electrically neutral. Antimatter looks exactly like regular matter, except the charges are flipped. The protons in the middle of the nucleus, instead of being positively charged, are negatively charged, antiprotons. The electrons going around the outside, instead of being negatively charged in matter, they're positively charged. Other than that, they look exactly the same as far as we know. They look exactly the same. So for every kind of particle that we have in matter, this huge list of all these different kind of particles that we can describe in matter, there are identical particles with that flip-flopped electrical charge as antimatter. Theoretically, at the Big Bang, when energy is converted into mass, matter and antimatter are produced in exactly equal amounts. It's just what happens. When energy is converted to mass, like the Big Bang explosion. So at the Big Bang, there's an exact equal amount of matter and antimatter. However, if you take a particle of matter and you take a particle of antimatter and bring them into contact with each other, they completely, totally annihilate each other and turn into energy. A piece of antimatter the size of a paper clip would literally annihilate most of the east coast of the United States. That's how much energy we're looking at releasing. It's an immense, immense amount of energy. And by our scientific theories, at the Big Bang, we should have created exactly equal amounts of matter and antimatter. So why didn't that happen? When we look out at the universe, what we see is matter. We don't see antimatter. Antimatter is very, 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 very rare. So they have a new theory. There was a very slight imbalance of matter over antimatter. So the matter particles, the antimatter particles came in contact with each other, they annihilated, but there was just a little bit more matter, and that's everything that we see in the universe. I love the explanation. They come up with these great explanations, but why would there be that slight imbalance? And why would that occur? You go back to that first bullet point. When we convert energy to mass, it creates equal amounts of matter and antimatter. That's what we observe. And yet they say, oh, but this new theory is that there was a very slight imbalance. But that goes against what we observe. The whole point of science, you can say anything you want. In science, you literally can theorize anything you want. But to make it legitimate, you've got to have evidence, experimental evidence, to show that your idea is correct. And that last theory doesn't match up with the observations that we make. So there's a big problem there. it's interesting how a lot of times what I see with the Big Bang Theory is the same thing that happened with the Earth-centered system of the solar system. Back with the Greeks, they thought that the Earth was in the center of the solar system and everything went around the Earth. Now, observational evidence, does that make sense? Yes. Right now, are you moving right now? Yes. Take away what we know. What do you feel? Do you observe that you're moving right now? No. We're sitting still. And yet, the sun moves across the sky, and the moon moves across the sky, and the planets move across the sky, and the stars move across the sky. Well, if I don't feel that I'm moving, and yet I see those moving across the sky, they must be moving. So that puts the Earth at the center, and everything goes around the Earth. Cool. That works. There's observations that fit that. But over the years, they started getting more and more and more observations that didn't fit that idea. That mindset, the geocentric system of the solar system, the Earth-centered system, was finally overturned partly by a guy by the name of Copernicus, came up with the idea of the sun-centered solar system. The sun being in the center, that's the big one, that sort of makes sense, and then everything else goes around the sun. And then there were other pieces of evidence that helped to support that. Newton's laws of motion, eventually, that was the big deal about Newton's laws of motion. Newton's laws of motion and his law of gravitation not only showed why the sun-centered system was right, but it also showed why the Earth-centered system was wrong. So over time, the Earth-centered guys just stuck little things. Oh, we'll make this exception, we'll make this exception, we'll make this exception, to make their Earth-centered system continue to work in the face of evidence that went against it. I see the same thing with the Big Bang Theory. We keep coming up with pieces of evidence, not creationists, other scientists coming up with observations that seem to go against the idea of the Big Bang Theory. So let's make this little tweak, well, let's make this little tweak and make this little tweak. And eventually it gets to the point where you've made so many tweaks that the theory begins to fall apart of its own weight and its own inconsistencies. And that's what really is happening a lot with the Big Bang Theory. That was 8 pieces of what we refer to as unnatural selections that seem to indicate that there was some kind of a design, some kind of an intelligent design behind the existence of the universe. Hugh Ross, the astronomer, has a list of 25. We've only looked at 8. He's got a list of 25 different ones. Freeman Dyson, the Princeton physicist. I like Freeman Dyson. He's kind of cool. Interesting quote. The more I examine the universe and the details of its architecture, the more evidence I find that the universe, in some sense, must have known we were coming. And God said, "Let there be light." So where does that leave us? As biblical believing Christians, we have the Genesis account of creation as our guide. It works, it makes sense. But a scientist who believes in the Big Bang has that finely tuned intelligent design problem to have to explain and to deal with. And they just can't. It's there. They admit that it seems as if the universe is finely tuned, and yet the Big Bang. So we know the explanation, and it's interesting how each phase of creation ends with a very simple statement. And God saw that it was good. And that's what we see. He fine-tuned the universe to be in a form that works for us. It works for life. It works for living things. It was good. It was perfectly fine-tuned. And a compelling summary in Genesis 1. At the end of creation, God saw all that he had made. We defined that. What is all that he had made? The universe. He saw all that he had made, and it was very good. It was fine-tuned. It was perfect until we came and goofed it up. So we go from that, from the origin of the universe, that logically leads us to another step. What about us? What about life? The origin of life. And we get into that really, really, really closely related topic of the origin of life. Now again, any origin theory we cannot prove, because in order to prove it, we either have to make it happen again or go back in time and watch it happen. We can't go back in time and we can't make it happen again. Can't do that. Okay? So, both of these topics deal with origins, one for the physical universe, one for the biological universe. And that's what we're going to bang into. We're going to start into now today. So let me get out of this one. And I got to go here. And let's go into, oops. Open with PowerPoint. Thank you. I did make a copy of that one already, but that's okay. All right. So, evolution versus creation. Which requires more faith? If you think the Big Bang Theory takes a lot of faith, strap in. What is evolution? Now, what's interesting is the concept of evolution, the concept of change, and let's put this in the right context. Little e evolution versus big E evolution. Big E evolution, in my mind, is a religious belief. No different than our belief in Christianity. It is a belief that scientists have. Versus little e evolution, things can evolve, things can change. Little e, all right, not big E. That's a different entity here. Like little Darwin there. It is a theory. Now this is the big E evolution. A theory that species can change over time by natural selection. All right, the main concept of this came from Darwin. Notice it is a theory. It is not a fact. It is not a law. It is absolutely not a fact. It's taught that way in school, that it is a fact. It is not. It is a theory. It's an idea. I would even go as far as to say it's not even a theory, because there isn't an awful lot of evidence to be able to support it. I would take it back one step from that it is a hypothesis. It is not a theory. And we need to define a couple of terms. What's a species? In biology, a species is a kind, I use that word on purpose, a kind of organism that can reproduce with another of its kind. So, even though there are all kinds of different dogs, they are all the same species, because a Great Dane and a Chihuahua can breed and make another dog. What about a mule? A mule is taking a horse, which is one species, and a donkey, which is another species. Horses and donkeys are not the same things. They're not the same kind. That's that biblical term. But you can breed a horse and a donkey and get pregnant and give birth to an organism called a mule. Mules cannot reproduce. Mules are sterile. So a mule is not a species. A mule is not a new species. That's the key with species, is that they have to be able to reproduce, and then the offspring have to be able to reproduce as well. They are unique types, kinds of organisms. All right, in our biblical creation story in the Bible, it talks about that God created things according to their kind. That's what we're talking about there, this idea of species. Natural selection. What's natural selection? And this is an interesting one. The concept of natural selection is the idea of the survival of the fittest. That's what that is, okay? That the organism that is best suited to be able to survive does and reproduces. Do we have any problem with natural selection? Not a bit. If you've got a herd of antelope and there's a lion chasing that herd of antelope, the one that gets caught is the slow one. The slow one doesn't reproduce. The ones that reproduce are the fast ones. And over time, the antelopes tend to get faster. But they're still antelopes. They haven't changed kinds, and that's the key. That's the key. That is natural selection. Now, Darwin said, and that was something that was observed. We knew that. That was something that we did all the time. We did that. Farmers will do that with organisms. We've done that with dogs. The reason why we have so many different breeds of dogs is because they have, by artificial selection, human beings specifically choosing which dogs to breed with which dogs to produce particular characteristics. Yes, a Labradoodle, okay? A Dachshund, all right, long and skinny. Why? Why did they breed long, skinny dogs? To go in the tunnels, yeah, to go after rats and badgers and things like that, okay? They specifically chose particular characteristics and bred for those characteristics. We do the same thing with crops. All right, with fruit trees and things like that. We selectively breed, we selectively make those things reproduce to get the characteristics that we want. But the key there is they never change species. They're all still the same species. What Darwin said was that species change over time. That's the big change. That's where Darwin came in. That all species have a common descent. Humans came from apes. Yeah, okay. That all modern day organisms have a common ancestor based on common traits. And that because common traits, that we have a head and we have two arms and we have two legs just like a monkey does. So that means we must have a common ancestor because we have common traits. That's Darwin's mindset. That's Darwin's idea. And that this change is very gradual and very slow over time. Yeah, gradual change over time. We've done that. Again, I keep coming back to dogs, but it's one of the best examples. It does happen. It's a slow, gradual change that happens over time. But, and he says that change happens due to natural selection. But the problem is that change is not changing species. Every single dog that exists is still a dog. We haven't changed species, we've changed traits. Just like each one of us looks different, dogs look different too for the same reason, but they're still dogs, all right? In some ways, we can think that way because they talk about, oh, well, we have the different races, the different races within humanity. No, we're all the same. It's no different than the different breeds of dogs. They have different physical characteristics. We have different skin color or different heights or different facial features or different hair color, things like that, and yet we're all still human beings. We can all still mate and produce offspring that can produce offspring. We are all the same species. We're no different. And yet, again, the secular mindset would be to try to separate us based on our race. Well, dogs, it's the same way. They're all still dogs. They're all the same species. They don't change. This change being slow and gradual over time doesn't always happen. One of the examples that they always use in the textbook is it was a moth that was in England, a spotted moth. And that particular moth could come in two different varieties. One was white-colored wings with black spots, and the other was black-colored wings with white spots. And the most common version of that moth in the 14, 15, 1600s in England was the white version with black spots. Because when that moth would land on a tree that had this particular lichen on it, it was a plant that grows on the sides of trees, that was white with black spots. So the moth lands on the tree, you can't see the moth. Camouflage. If you put a black moth with white spots against that white tree, predators can see it, so they get eaten. Cool. And then we get the 1800s, late 17, early 1800s, and the Industrial Revolution. And what does Industrial Revolution produce? Air pollution, soot. And the soot gets on the trees. And now the trees are black. And all of a sudden, the population of the white speckled moth goes down, and the population of the dark speckled moth goes up. They're the same species. They're the same moth. All right? If you want to think of like a person that's white and a person that's black, that's what it is. They're the same species. The one has white coloration, the other has black coloration. The black coloration one became the most common by natural selection because the trees now were dark and the white ones were getting eaten. But it didn't change the species. They're still the same moth. Evolutionists will use that example as an example of evolution, except for the fact that it's not evolution. It's change in population. All right? It's change in the population numbers because of a characteristic of the environment that has changed, not because the organism has changed. It's still the same moth. And that's the piece that they can't explain, because what they say is if there's enough changes to the organism, we get what they call speciation, change of species. Compare a Great Dane to a Chihuahua. Are there a lot of differences between a Great Dane and a Chihuahua? Yup. There's a lot of changes there. There's a lot of differences. And yet they're still dogs. They're still dogs. They didn't change species. And that's where Darwinian evolution, it falls apart. Because you can use those explanations, but it still doesn't explain what's going on. Keep in mind something, and we'll wrap up with this, and we'll get more into detail next week. I have zero problem with the concept of natural selection. Natural selection happens. No problem whatsoever with that. The slow antelope is the one that gets eaten, and the fast ones don't, and the fast ones reproduce, so the antelopes get faster. That's natural selection. Okay? The white moths now on the black trees get eaten, so you get more black moths reproducing than white moths, so we see more black moths. No problem with that. That's natural selection. Not a bit of problem with that. The problem is, or the issue is, that is a concept that causes population distribution changes, not change of species. There is no evidence of natural selection causing a change of species. It doesn't exist. They may say it does, and that's what we're going to be looking through over the next, I don't think I'll be able to finish it next week. It's probably going to be 2 weeks looking at evolution. They'll say it, oh yeah, oh, here's this evidence and this evidence and this evidence and this evidence, but none of it is that. None of it is that change of species because of natural selection. It's change in population distribution, not change of species. And then, of course, if we go all the way back, let's go all the way back, that life starts just with this primordial soup, these chemicals that just randomly combine, and we get living things, and living things get more and more and more and more complicated over time. The problem with that one, and we'll see this later, that violates the second law of thermodynamics. Because the second law of thermodynamics says that over time, things get less and less and less and less ordered. Evolution, by definition, requires it to go the other way around. The other problem with evolution is it doesn't explain things that don't change. The great white shark, great example. If we look at the great white shark, you look at a great white shark today, and you look at fossil versions of great white sharks. They say it's a different species called Carcharodon megalodon. That's a shark, a great white shark. We've seen Jaws, yeah. Jaws, the shark in Jaws was 20 to 25 feet long. Megalodon is about 75 to 100 feet. Its jaws would be bigger than that door. Its teeth, an individual great white shark tooth is about that big. A megalodon tooth is about that big. And yet, they look exactly the same with one difference. Size. They look exactly the same, just different size. You've got these different organisms, the horseshoe crab, okay? If you look at a horseshoe crab today, there are fossils of horseshoe crabs that are supposedly millions and hundreds of millions of years old, and yet they look exactly the same as a horseshoe crab from today. So why did horseshoe crabs not evolve? Or why did organisms evolve from horseshoe crabs into other things, and yet horseshoe crabs are still here? That makes no sense to me. Cockroaches, same thing. Dragonflies, same thing. We've got fossils of dragonflies. Yeah, fossil of dragonflies with wingspan like that. And yet they look just the same thing as a dragonfly today that's this big. That's not a different species, that's just different size, all right? That's no different than a small person and a big person. They're the same species. There's no explanation for that. Why do some organisms evolve? Why did we evolve from apes, but the great white shark is still the same as it was 100 million years ago? They've got no explanation for that one. Because their entire thing is a belief system. It's a worse belief system than ours. We have evidence to show our belief in where the universe came from and where creation came from. And again, we'll be looking at not only the evolutionary aspect, but also the creation aspect as well. All right? So with that, let's close. Again, we're going to continue onward next week and start looking at, with a question mark, the evidence for evolution. All right? Lord, we thank you for this day. We thank you for the blessings that you give to us, for safety and travel today in this brutally cold weather, Lord. We thank you for bringing everyone out today. Thank you for giving me the words to be able to speak, the clarity. Pray that you continue to be with us, be with our morning service. Have the message come out clear and strong for us today, and as well as our meeting this afternoon, that all would go well. All these things we ask in your Son's name. Amen.